Hey there, everyone. I'm Dr. Flux, and welcome to the very first lecture in our journey into psychology. Today, we'll be diving into something fundamental: how we build models of our world and of ourselves. But before we get started, I want to give a shout out to the instructors who helped develop the PSYC textbook that was the primary source in developing these lectures, and whose slides helped me out a lot in developing my own. That's Dr. Ryan Curtis, Dr. Scott Roberts, and Dr. Dylan Selderman. In this first lecture, we'll be using an example to introduce you to the idea of models. We'll then dive a bit more deeply into what a model is, and segue into how psychology is a science, introducing the ABCs of psychology. We'll wrap up by comparing psychology to a few other fields, and then conclude with a bit of review. Let's start our journey with a story. Picture this. It's a crisp, snowy morning, and I've decided I want to hit the slopes in Breckenridge. I've got my Epic Pass ready, and I'm absolutely psyched. But there's one question. What's the traffic going to be like? So, like any modern human, I pull up Google Maps. Here's a map of Colorado, or at least part of it. I can see two routes to Breckenridge, each with potential driving times. And it's perfect. But wait a second. Am I looking at the state of Colorado? Now, you might say, well, yeah, Dr. Flux, that's a map of Colorado. But let me rephrase that. Am I looking at the actual state of Colorado? Not really, right? I'm looking at a representation. A map isn't Colorado itself. It's not showing me every tree, blade of grass, or squirrel along the way. It's a simplified, colorful version of reality. So if this map isn't the true Colorado, how can I trust it? How do I know it'll actually get me to Breckenridge? Well, the thing is, a map doesn't have to be 100% accurate to be useful. It's missing a lot of details, but it still helps me to get where I'm going. Now here's another question. Are these two travel times that Google gave me exactly how long it'll take to get to Breckenridge? Probably not, right? There's so many variables that Google can't account for. Maybe a herd of elk decides to cross the road, or maybe there's an avalanche somewhere that slows things down. These travel times are based on algorithms using previous traffic data, road closures, and even some real-time driver updates. Now, they're wrong in the sense that they aren't precise, but they're still useful. And maybe I'll get tired of Google Maps travel times at some point. Maybe they aren't really accurate enough for me, and so I'll switch to Apple Maps. Apple Maps uses different algorithms to predict my travel times. I might decide that their models are more useful for me than Google Maps' models. Or perhaps I'll switch back and forth depending on where I am in the country. Maps, travel times, these are all models that I'm using to plan my trip. And like any model, they leave things out. But that's okay. Models don't have to be perfect. They just have to be helpful. This brings me to one of my favorite quotes. All models are wrong, but some are useful. By George E.P. Box, a British statistician. No model will ever fully encapsulate reality. We build models as shortcuts to make the vast complexities of reality easier to work with. Some of those models will be more useful than others. In science, we're trying to build useful models, while knowing that they will always fall short of reality in some way. Models are representational. They reflect reality. They help to simplify complex systems, and they help us to predict what's coming next. Let's check to make sure you've been paying attention. Throughout these lectures, I'll often pause to ask brief questions to check up on your knowledge. This should be an easy one. Fill in the blanks. All models are blank, but some are blank. Is it A, helpful but false? B, Earth but Colorado? C, wrong but useful? Or D, true but falsifiable? The correct answer is, of course, C. I hope you're keeping up. Think about how we do this in science. In physics, we've built models for centuries. You're probably familiar with some of them. Newtonian physics works great for predicting the motion of objects, but eventually Einstein's theory of special relativity replaced it. Now we've got quantum mechanics, which takes things even further. But here's the catch. Even in physics, none of these models are right. They're tools, simplifications, that let us understand the principles of the universe. And as we gather more data, we refine or replace our models. Psychology works the same way. It's a science, just like physics. But in psychology, we're building models of phenomena that are often a lot harder to pin down. We create models to understand emotions, behaviors, and thoughts. Now you might be saying, but Dr. Flux, psychology isn't the same as physics. There aren't as many numbers and formulas. Well, let me tell you, if you want numbers and formulas, just ask me about using Bayesian statistics and signal detection theory when I was studying visual psychophysics back in my days at NYU. Science is empirical in that it relies on being able to make repeated observations about a phenomenon. Science is systematic in that it uses structured methodology to accomplish these observations. Science seeks to be objective, looking to find patterns that exist outside of opinions and beliefs to reliably explain the world in many contexts. In science, we make predictions that are falsifiable, such that they can be tested and we can see whether our predictions are useful or not. And science is iterative. It builds on the knowledge of the past to continue to come up with new and insightful ways of understanding the world. Psychology does all of these things. However, the things that we study in psychology tend to be a lot more challenging to pin down, which is probably why people call it a soft science. How do we study something like love? How can we understand consciousness? What methods do we use to capture human thought and emotion? These are complex topics that are often difficult to pin down. But that's what psychology does. It's looking to understand ephemeral and sometimes contradictory concepts. Psychology builds models to explore questions like what causes stress? How do we form memories? Why do people make irrational decisions? In psychology, we stick to the ABCs. The American Psychological Association, or APA, describes psychology in the following 3 words. Affect, or feelings. This includes emotions, moods, and stress. Behaviors, or our actions, which includes habits and our observable patterns. And cognition, or our thoughts, beliefs, memories, and decision-making fall into this category. Breaking it down a bit further, when we refer to affect, this is different from effect. Affect is a very specific concept in psychology, and it refers to how we feel. I teach a class in human emotion that dives deeply into the philosophy and science of how we understand how we feel, and it can get incredibly complex. Emotions, moods, well-being, this is the domain of psychology. How do we understand this basic component of being human? Why do we feel things in the way that we do? And why do I find sea otters so dang cute? Behaviors are how we act. How do we decipher actions and create predictable models that explain what we do and why? Do we have free will? Do people act different in crowds than they do on their own? Why did someone in Germany turn me into a meme questioning my style choices? Our cognitions are how we think. They encompass our beliefs, memories, and how we make decisions. Can we trust our memories? How do we process information? Why did people used to think that cocaine was an effective treatment for toothaches back in the day? Let's do an attention check. Which of the following is not one of the ABCs of psychology? Is it A, affect or feelings, B, behavior or actions, C, cognition or thoughts, or D, culture or traditions? The answer here is D. While we definitely look at culture in psychology, we often explore it in the context of the ABCs, affect, behavior, and cognition. Before we wrap up, let's clarify how psychology differs from some related fields. Sociology focuses on groups and societies, while psychology zooms in on the individual. Anthropology looks at human cultures over time. Psychiatry focuses on medical treatments for mental health. And political science studies systems of governance and policy. It's related to psychology, but not the same. Each field builds models, but they're tackling different aspects of the human condition. and they're often doing so from different perspectives and using different methodologies. Here's my challenge to you. Think about the models you rely on every day. When you predict how a friend is feeling based on their tone or body language, you're building a model. Ask yourself, when are these models useful, and when might they be wrong? Let's do 2 review questions before we close. Which of the following best describes a model in psychology? A, a complete and perfect representation of reality. B, a simplified version of reality that helps us understand and predict phenomena. C, a subjective opinion about human behavior. Or D, an unchanging scientific law. The correct answer here is B. A model is a simplified version of reality designed to help us understand and predict phenomena, even though it may not capture every detail. According to the American Psychological Society, or APA, which of the ABCs of psychology refer to feelings? A, actions, B, attributions, C, allotment, or D, affect? If you chose D, you've got it. Affect is how we discuss feelings in psychology and helps us to build models of the human emotional experience. In this course, we'll be examining many different models that attempt to explain these ABCs. Some of these models may contradict each other. Some models will work better in certain situations and less well in others. I want you to keep in mind that each of these models is a simplified way of understanding our very complex human experience, and none of them will ever fully capture all of the nuances that make up the complex, messy world of human thought, behavior, and feeling. In the next lecture, we'll be exploring a few of these different models that are currently used to help us build broad approaches to psychology. I'll leave you with my usual end-of-lecture sign-off. Stay curious, stay resilient, and above all, live life in flux. I'll see you next time. Flux out.